Right, so question 4, what's occurring? I've got a function. We're dealing with radians, which is a bit annoying. And some of these statements are going to be true. So the maximum value of this function is presumably one of these. The maximum value occurs when, presumably, one of these. Okay, so what we're going to do is try and figure out what is true, what's happening here. Function is 2 minus sine of x minus pi over 3. So let's just think about sine for a minute, shall we? Here is my graph of y equals sine x. It starts at 0 and it kind of oscillates around like this. That's about 180, that's about 360, but we were dealing with radians stuff. So when I say 180, what I mean is pi, and when I say 360, I mean 2 pi. Right, where is the maximum and minimum value of this function? What does it do? Well, it goes between minus 1 and plus 1. Okay? So the sine bit is always stuck between plus 1 and minus 1. And what that means is when I have my function here, my function is apparently 2 minus 3 sine of x minus pi over 3. But basically this bit is somehow stuck between minus 1 and 1. So what happens when this bit equals minus 1? What happens when this bit equals 1? So what's going to happen is, let's just kind of do it here. So when this is minus 1, I've got 2 minus 3 times minus 1. So this is times together, obviously. So that's going to equal minus 3 times minus 1 is plus 3. So I've got 5. At plus 1. What's going to happen? I've got 2 minus 3. So 2 minus 3 times 1, which is actually 2 minus 3, which is actually negative 1. So actually, these two values do come out of my function. And these were the two values in the question, it turns out. Obviously, this is the maximum because it's bigger than this one. This is going to be the smallest possible answer. This is going to be the biggest possible answer. Okay. Interestingly, the biggest answer happened when this part was the smallest one, was minus 1, and that's because I'm taking it away. Take away the smallest number and you get the biggest answer. Take away a bigger number and you get a smaller answer. So anyway, this is true. That is a maximum value. So then we have a bit of fun and we have to say, when does this happen? It happens when this bit equals minus 1. Which is here. So let's just add some more points. That's half of a pi. That is 1.5 pi's. We normally write 3 pi over 2. So when this bit is inside my sine function, I get the answer minus 1, which gives me through to 5 at the end. Okay, so this bit in my sine function has to be worth this. So what I just said, the bit in the sine function has to be equal to 3 pi over 2. That's a bit of a mess. The easiest thing to do is probably to, well, let's just add that both sides. Let's do x equals 3 pi over 2 plus pi over 3. Adding fractions, looking for a common denominator. So what's going to happen is I want to get these both out of 6. So to get this out of 6, I'm timesing top and bottom by 3. So it's 9 pi over 6. Times them both by 2 plus 2 pi over 6, which is going to be 11 pi over 6, which is a bit ugly, but it's also one of the answers. So I'm happy. Okay, and you can check it, right? If you want to just check, chuck in x equals 11 pi over 6 into here, work it through. I mean, if it was a calculator paper anyway, you could just do sine of the answer very easily, and then work it through, and you'd find out that you get the answer 5, and that all makes sense. So there you go. The answers are B and D. So let's answer the actual question. Therefore, B and D correct. There we go.